Hello everyone, and welcome to this video where I'll be taking you through a question on the objective. Identify a curve defined by trigonometric parametric equations by plotting points. So in this video, I'm going to be going over one sample question from Knewton.com in their Knewton Alta homework system. And I'm hoping that watching me go through this one here will help you out when you're working on similar problems, related to that objective on your own. And as I always say when we go over a new question, before you watch me do it, pause the video and try to work it out yourself first. And then come back, watch me go through it, and see how you did. Compare your work to mine, see if you can take anything away from it. Okay. So here's the question I wanted to work on today. We're asked to determine which graph is the sketch of the curve described by the parametric equations x of t equals -4 times the cosine of 3t, and y of t equals -4 times the sine of 3t, where the value of the parameter t ranges from 0 to 2 pi over 3 radians inclusive. All right, so this kind of a problem here in Knewton Alta is a multiple choice problem, but I'm going to work it out by hand first, draw a sketch of this by hand, and also go to that desmos.com graphing calculator website and take a better look at it there. And then we'll come back and verify the solution. All right. So we're given the following equations. All right, x of t is -4 times the cosine of 3t. All right, so this is going to give me the x coordinate of whatever location I'm at, depending on the value of t, and then the y coordinate of whatever location I'm at on the xy plane is given to us as y of t equals -4 times the sine of 3t, and the value of t, we're told, is in this range, right, from 0 to 2 pi over 3, right, including 0, including 2 pi over 3. All right, so I'm going to put up a similar table to one we've seen before with trigonometric parametric equations, where one column will have values of t, and then for each value of t I plug in, we're going to get the corresponding value of x, right? So I'll have the x of t column and the corresponding value of y in another column, y of t. And I'm only going to plug in values, ranging from 0 to 2 pi over 3. That will end up being nice values, right, when I plug them in to the equations. And I notice that the expression inside the cosine and the sine are both 3t. So I'm going to put in some nice values like 0, and then maybe go every pi over 6, right? Because if I go up every pi over 6, this will really be taking t and multiplying it by 3 pi over 6, which is pi over 2, right? And every pi over 2 radians was a nice value, right? Remember, for your trig functions, especially for sine and cosine. All right, so I'm going to go pi over 6 after that, then 2 pi over 6, which is pi over 3, then 3 pi over 6, which is pi over 2, then finally 4 pi over 6, which is 2 pi over 3 when reduced, and that's where I'm going to stop, because that is the upper value on the range of t here. Okay, so let's see what our x and y coordinates are when we plug these in. All right, so I'm just going to say these out loud. I'm hoping that you remember your special values of the trig functions, cosine and sine and all that of some, your multiples of pi over 6 and pi over 4. All right. So when t is 0, the x value of our point, our location, 3 times 0 is 0. The cosine of 0, remember, was 1. And then this is multiplied by -4. All right, so the x coordinate's -4. And then the y value, the y coordinate when t equals 0, again, 3 times 0 is 0. The sine of 0 would be 0 times -4 is 0. All right, so I'm going to do this over here. I'm going to make a sketch of our locations, our points on the xy plane. Obviously, if you have graph paper, that might be a little nicer looking. But for when, t equals 0, we're at the point where x is -4 and y is 0. Okay, so I'm at this location. I'll put it in a different color here. There, that point there. And this is when, e equals 0. I'll label that value of the parameter there so we know where we're at. Okay, when t equals the next value in my table, again, you don't have to plug these in. You can plug in any value you wish that's between 0 and 2 pi over 3. And I just picked some ones that I thought would be nice. When t is pi over 6, right, in the x equation, 3 pi over 6 is pi over 2. And remember, the cosine of pi over 2 is 0. All right, so then times -4 would be 0, the x coordinate. Then the sine of 3 pi over 6, the sine of pi over 2 was 1 times -4 is -4. Right, so I'm at the location on this location on the y-axis now. 0 for the x and now -4 for the y. Right, so we're here when t equals, pi over 6. Okay. Then when t is pi over 3, 3 times pi over 3 would just be pi. Cosine of pi was -1 times -4 is +4 for the x coordinate. And then the sine of 3 pi over 3, or the sine of pi, right, was 0 times -4 would still be 0. So when t is pi over 3, I am at the location 4 for the x, 0 for the y. I am here now. This is when t was pi over 3 radians. Pi over 2 for t. And the cosine of 3 pi over 2 is 0 times -4 would be 0. And the sine of 3 pi over 2 was -1 times -4 would be +4. So I'm at this location with an x value of 0 and a y value of +4. Oops, sorry about that. So this location here, 0, 4. This is when t equals, pi over 2. And then finally here, when, t is 2 pi over 3, all 3 times 2 pi over 3 would just be 2 pi. And then we're pretty much back to the beginning. The cosine of 2 pi is 1 times -4 would be -4. And the sine of 2 pi, right, would be 0 times negative 4 would be 0. So we're back here. So when t equals 0, t equals 2 pi over 3, we're back at that same location. All right. So now there's only 4 points. Right? There are only 4 points on this graph. Now, I know you're probably tempted to just make a little box out of this, connect these with straight lines. But let me refresh your memory, hopefully, that the cosine function, the sine function, remember the trigonometric functions were also referred to as the circular functions. So when you're connecting points, if your equations are involving the trig functions, chances are you're not connecting points with straight lines. This is more than likely going to be a circle. So I'm going to draw that. So we started here at negative 4, 0, and then draw a little circle where we go around in this counterclockwise fashion. Also put the arrows on. Remember, for parametric equations, you're also putting on the orientation of the curve, right? You're showing where the particle or where the point is moving as the value of the parameter increases, right? So from 0 to pi over 6 to pi over 3 to pi over 2 to 2 pi over 3, we're going in this counterclockwise direction around the circle. Now, if you don't believe it's a circle, just plug in more values, right? So instead of going every, pi over 6, maybe you would go every, I don't know, pi over 12. Plug in with smaller intervals between. If t were, I'll just throw one more of them in there. Maybe let you hopefully believe that this is more of a circular thing. So yeah, let me do that. So I'm gonna put in, let's try pi over 12. Now 3 pi over 12 is pi over 4. Cosine of pi over 4, what was the square root of 2 divided by 2, but then times negative 4 would be, negative 2 times the square root of 2. All right. And then the sine of 3 pi over 12, the sine of pi over 4 was also square root of 2 divided by 2. And times negative 4 would again be negative 2 times the square root of 2. Now, square root of 2, right, is about 1.4. So this is double that. This is about negative 2.8. So between negative 2 and negative 3 here, and then between negative 2 and negative 3 here, so we're about here. This is what the location would be when you're at, t equals pi over 12. And it's not on a straight line with these 2 points here, so there's definitely some curve going on. Right? And you can plug in other points if you want to see more of the circular motion going on here. Okay, but there we go. There it is. Graphed it. Now let me show you a better looking picture, right? This was a hand drawing. Let's go to that Desmos website. All right, so here's desmos.com, free online graphing calculator. Now, if you're going to be plotting parametric equations on the xy plane, you have to enter things in Desmos as if they were an ordered pair, right? So I'm putting a left parenthesis, and then the x coordinate in terms of t was, negative 4 times the cosine of 3t and then a comma. And then the y coordinate in terms of t was negative 4 times the sine of 3t. Right, and close that off. And I'm going to make sure I'm in radian mode as well, right? So off to the side. On the right side, I know you can't see it, but that'll be like this wrench picture. You pull that up, it's graph settings. And you can see I'm in radians as opposed to degrees. And the range, right? So when you do that, right, you put in the ordered plural with the t's involved. then you'll see a range for the values of t pop up. So it starts off 0 to 1. So I'm just going to go, 0 to 2 pi over 3. And you see this circle pop up, right? This is the same circle that I drew by hand with a center at the origin, radius of 4, right? If 4 is 0, 0, 4, -4, 0, 0, -4 are all on this. But the only thing you can't see, right, is what direction the point was moving in to make this curve, right? I put the little arrows, right, on the circle on my hand drawing to indicate the direction or the orientation of the curve. So if you'd like to do that in Desmos, do the same thing I did earlier with t, but just change t to some other letter. All right, because when you put in t's here, it just automatically pops up with this range of t. Just do it again with some other letter. So I like doing S for t, right? So I'm going to have S represent t here. So we have the first, x coordinate is -4 times the cosine of 3s, comma, and then the y coordinate -4 times the sine of 3s. All right, so you see what happens there is instead of giving a range for s, it asks you to add a slider for that letter. So I'll do that, label it. So there, you see this blue point show up on the curve. And when I hit label, the coordinates came up 3.9 something, -0.5 something. That is the location we are at when s equals 1, right? It automatically starts off at s equals 1. So let me change the range of s. I'll change it from 0 to 2 pi over 3, just like for t, right? S is acting like t. And then this step size is, how far apart are each of the values of s you're going to be plugging into your table. On my table earlier, it was pi over 6, right? My step size was pi over 6 on the table. But just to make it nice and smooth, and we're going to watch this circle be traced out nicely, I'm going to go a small step size of 0.01. All right, let me move s. Again, s is like t. Move this back to 0. So you see how the point starts off at the location -4, 0. And then I know you can't see it, but to the left of s equals 0 here, where my cursor's floating around, there's a play button. I can hit play, and it increases the value of s up until the 2 pi over 3, and then back, shrinks it again. Now I'm going to slow it down a little bit. Go back to 0 and hit play again. So you can see the point moving along this curve, tracing this curve out as the value of the parameter goes up. Right. So this is the motion being described by our parametric equations, this circular motion. And play around with this, change the step size, make it bigger, make it smaller, change the plane speeds. You can use letters other than S and it still works the same. But yeah, so just play around with Desmos and hopefully you can learn something, pull something out of it. All right, so back to the problem. And it was a multiple choice thing. So it's not this first one, right? This is an ellipse, not a circle. This looks like it, and yes, you see the little circle here is filled in. I'm in like this instructor mode where you can see the solutions. Obviously, you won't see them immediately. But there it is, right? This circle centered at the origin with a radius of 4, and you see the arrow is pointing in a counterclockwise direction. That's it, right? This one's a circle, radius of 4, but the arrow is going in the wrong direction, right? It's got to be this one with the counterclockwise. And great. All right, so hopefully watching me do this here helps you when you're working on similar problems on your own. And thank you very much for watching.